At Acclivity, we're pioneering event-native API infrastructure by way of a multi-protocol agent service proxy called Zilla. With Zilla, you can define open and async APIs that browsers, IoT devices, and microservices can use to seamlessly consume and produce data in and out of Kafka, or more specifically, Confluent Cloud. Zilla can be used for a multitude of exciting use cases, and for this demo, we're going to focus on IoT. So we'll deploy Zilla in front of Confluent Cloud and then create an MQTT entry point that IoT clients can use to publish and subscribe to and from the cluster. We'll also configure an HTTP entry point to show how a single Zilla instance can support connecting different types of clients to Confluent Cloud, helping achieve a unified interface to all of your streaming data. All of this configuration will happen declaratively and without any external tools or dependencies, so there will be no coding, no Kafka Connect, or any other intermediaries involved. Let's jump in. To start, we'll head over to AWS Marketplace, where there's an offering called Zilla Plus for Confluent Cloud. It's worth mentioning that Zilla is open source, and Zilla Plus is an enhanced commercial version that has an additional features and integrations, as well as comes with enterprise support. So let's subscribe to the offering. On AWS, Zilla Plus can be configured via CloudFormation templates. So that's what we'll do. Click Launch. All right, great. So here we can upload our CloudFormation template that we created for the purpose of this demo to help configure and deploy Zilla. And there we go. So if we fast forward a bit, here are the details required to deploy Zilla Plus. We've described our Confluent Cloud configuration over here. We've specified the different types of ports to be used by different clients. So 7143 for HTTP clients, 8883 for MQTT ones. And then Zilla Plus also supports custom domain names. So the MQTT and API and HTTP APIs that we'll create with Zilla here will leverage the acclivity.io domain. In our Confluent Cloud console, you can see we've created a few topics. The main ones are MQTT messages and events. As the name suggests, MQTT messages is the topic we will publish and subscribe to with our MQTT clients, and events is the topic we will do so with our HTTP ones. You might notice there are a few other MQTT topics that have been created. And these are used by Zilla to manage MQTT client state. I'll emphasize that Zilla is not just proxying MQTT messages on and off of Confluent Cloud, it's actually turning the cluster into a fully fledged MQTT broker, meaning all of the state and connectivity management features of a dedicated MQTT broker, such as qualities of service, last will and testament, etc., will be available in our deployment. Necessary topics created in our cluster and Zilla Plus has been deployed, we can get to the fun part, which is publishing messages, MQTT and HTTP messages through Zilla into Confluent Cloud. To do that, we'll be using Postman as a client, which supports both MQTT and HTTP. So over here we have our workspaces. We'll start with MQTT. Here's the URL for the MQTT API that we created with Zilla. We see the custom acclivity.io domain, and here's port 8883 that we specified in the CloudFormation template. So if we click connect, we'll see that there we go. Postman has successfully connected through Zilla to our Confluent Cloud cluster. And now we can send this message, hello Confluent Cloud sent via MQTT, to the Zilla topic, MQTT topic, which is mapped to the MQTT messages topic in Confluent Cloud. So if we go back here, we should see that message appear over here. I'll give it a little bit of time to load. Yep, there we go. We see that the message has successfully arrived in the MQTT messages topic in Confluent Cloud. The client and Postman is also subscribed to Confluent Cloud, so that's why we see the message appear here in the response. So not only did we produce the message to Confluent Cloud through Zilla, we've also subscribed to Confluent Cloud through Zilla, and once we publish that message, it got relayed back over here. With HTTP, we will go into the HTTP workspace, and here is the URL of the HTTP API that we've created. Again, Activity.io domain, the 7143 port we specified in the CloudFormation template. And similarly, we'll publish a message, hello Confluent Cloud, but this time sent via HTTP with the Postman client. Okay, looks like it went through. So if we go back to our topics and we go to events, we should see the message appear. So, yep, there we go. We see that the message, hello Confluent Cloud, has showed up here. So just like that, in under 5 minutes, without any coding, Kafka Connect, or any other stateful middleware, we turned a Confluent Cloud cluster into a fully fledged MQTT broker. And we also made our cluster seamlessly reachable by HTTP apps. There's much more that Zilla can do, from supporting event meshes by bridging gRPC and Kafka deployments to enabling data streaming partner access. But our goal today was to provide a glimpse into how Kafka teams and IoT environments turn to Zilla to achieve a unified interface to their data in motion.